Hi everyone, I am going to show you how to work with principal component analysis. I have been teaching principal component analysis for some years, and every time that I have to teach principal component analysis, I have some troubles. My trouble was that I don't have a free and open source software to work with my data set. Now I am going to show you how you can do it with your students using a free and open source software. I am going to use the R project. In here, I am going to use this software to do some exercise with my students. Well, the first thing that I have to do is to open my software. When my software is opened, I have to load my package. I am going to load this package. I am going to load my package. Well, let me tell you a history. This software don't have a visual interface. Most of the students were familiar with a visual interface. Now I am going to load. I just have loaded a commander. This package could be inserted and loaded in my software, and it has a very visual interface, and students find easy to work with them. I am going to Tools, load my package, and I will do OK. Now my package it's opened. Now I can load my data. For example, I have selected some examples to work with my students. These tables were provided and support information of your manuscript. And I suggest that you can download these tables and you can save it in a place that's easy to access. For example, I saved my tables in my desktop. Now we have several tables. The first table that we're going to work is table 1. Table 1 has electronegativity, atomic radius, ionization energy, electron affinity, oxidation states, standard states, group block, year of discovery, and atomic number of some chemical elements. My chemical elements were showing here. This example is one of the best to begin your work. Why is the best? Why I use this example to begin my class? Look, students were familiar with the periodic table. In here, we just have representative elementals, that is alkaline earths, high earths, halogens, and students know that samples, in this case, samples were chemical elements. Students know that how chemical elements could be grouped. For example, chlorine must be placed close to fluoride. Lithium must be placed close from sodium. And we can use this data as introductory example. For example, the first thing that I have to do in my software is to load my data. I'm going to load my data. Looking to this table, you can see that we have some missing information. For example, I don't have electronegativity for beryllium. I will insert this data in my software. I am tell the software that I have variables names in the file, and the first row of my table is the name of the variables. I am putting here a blank space. I am showing to the software that missing information are represented by a blank space. Now I just need to load my data. I am going to load my data. Now my data is loaded. Once that my data is loaded, I just need to click in Principal Component Analysis, and I will do it. Now, I have the loadings plot and the score plot. I have in here the variable factor map and the individuals factor map. This space that have this space that have I have in my table 5 variables. Sorry, I have in my table 6 variables: atomic mass, atomic number, electronegativity, electroaffinity, ionization energy, and atomic radius. I can compress these 5 variables to a 2 space variables. I am showing here. My original variables are compressed to just 2 variables. This graphic shows the contribution of any of my original variables to ASH principal components. I'm going to show you in here. You can see it right in there. And my samples were placed in here. Let me tell you something. You don't have a good interfacial, you cannot manipulate well images in R. Thus, we use the Chem. How can I use Chem? I'm going to show you. I am going to my software. And I will load my data in Chem. I am going to type library. Factor Chem. Now I can load my data in Chem using my web browser. I am going to do this. I'm going to type Chem dataset. In here, I have my variables. In here, I have my principal component analysis. In here, I have my individuals. And I have my original variables that were compressed in 2 principal components. You can see it right in here. You can see that atomic mass was highly related to atomic number. I can go to here, show principal component analysis parameters. I can go to there. In here, where we have all. Just show that I'm going to using all numerical variables to do my principal component analysis. I can choose, for example, I could take some variable out, for example, atomic number. I can just take it out. Now I just take atomic number. Atomic number is the same thing that atomic mass, and I don't have any difference in my principal component analysis with this trouble. In here, I could select supplementary variables. I have, for example, group blocks. I can go to here, show graph options, and I go to here. Points color depend of categorical variables. I am going to do, and now I have my distribution of individuals, and they are grouping according with the periodic table. We have the halogens in here. I have alkali metals in here. I have post-transition metals in here. We have metalloids between non-metals and metals. It's very easy to do it. I can do in here. For example, graphical of individuals. I can go to graphical of individuals. Now I can move it. When I do it, I make my... When I do it, I make these numbers bigger or smaller. I just can do it in here. And I can go to here, select the contribution. When I go to here, I will just have my elements show like points. Some things it is interesting and you can just use this option. Sometimes it is interesting because the name of samples were not important. Now you know how to load your data and how can you work with that. For example, we can do it again. I can load another data set. For example, in my manuscript, and when I give these classes, I begin grouping chemical elements of the representative family. And then after that, I do it using all the chemical elements. I just take off from this data sets halogens like I have done in the first example, and I take out these elements, the block F elements. How could I load my data? I will do exactly as I have done before. I'm going to Factormine. I'm going to here to load my data. I'm going to specify, and I will choose my table. My data is in table S2. I have just loaded my data, and I can do my principal component analysis on my data. Now I have all the chemical elements, and I have used another variables. I have done my principal component analysis again, but now I have used another variables. My variables are density, melting point, boiling point, atomic mass, atomic radius, electronegativity, ionization energy, and electron affinity. I have done this again, but now I have used all the chemical elements, and I have used the 3 more variables. Once again, I don't have a good choice to work with images just using my R commander. How could I do? I have to edit my files. If I want to manipulate my images, I need to go to the chain. Well, first I have to close the app. I am going to here, quit the app. And now I am going to load this data in Shiny using my web browser. I am going to here, and I will do. I have to type in here, PCR, principal component analysis, Shiny, dataset. Now all my data is loaded in here, and I have my variables that were transformed into new components, and I have my sample distributed over this space. I can go to here, show principal component parameters, and I go to here to block group. I am going down, show graphic options. I am going to here. Points color depend of the categorization variable. And now my chemical elements were shown according with the category. Então, look, I have transition metals in here. I have halogens in here. I have non-metals in here. And I have alkali metals in here. I have alkali earths in here. And I have in here metalloids between non-metals and metals. If you can look to this graphic, it is very polluted on the middle. Look, I can see that I have in here gold, fluoride, but in the middle of the graphic, it's quite difficult to see it. Well, I could export this image to have a better look, but I can just show some of my data points. For example, I could go to here, graphic of the individuals. I am going to here. I have no selection. I go to contribution. In the contribution, my program knows that I have this number of samples. That is the number of elements that I am working. And I can put down to show just the elements that have the higher contribution to my model. For example, if I go to 1, I am going to look in here. All my chemical elements were substituted by points. These points are shown according to their color. It's quite difficult to see the colors in here. I could do this graphic higher. I can do these points bigger. I just need to go to here. I'm going to here, and in here I am going to do my points bigger. Look, I go to the maximum. I have my points bigger. Our biggest trouble is that Shiny show categoricals. For example, I cannot take off halogens, transition metals, metalloids, and the graphic was not good to see. Well, I give it back to here. I am going to this size, and I can show just some of my elements. For example, I go to choose just this number of elements. And look, the graphical is less polluted than before. I can see just elements that have more importance to the models. For example, in here, I am showing some of the transition metals. In here, we have the halogens. I have non-metals. Now that I have the option to show just the number of some of my samples. For example, in here, I have the names of all my samples, but in here that we have several samples, it's very difficult. It's very hard to see the number, the symbol of my chemical element. Look, in the middle is very difficult to see the symbol of my chemical elements. It's quite hard you do it. So you can go to here and you can choose to just show some of the elements. Here I am showing all the symbol of my chemical elements. In here I am showing just some of them. You can export your image. How could you do it? How could you export your data? Just clicking here. I don't like this format. I prefer to use this format. I just need to go in here, give it download, and now my file could be saved. I can do in here. I can do it in here too, and I can download my file. I can download my image. Well, after that, you know how to load your data and how could you manipulate it in your software. I can show you some more examples. For example, I'm going to your tables. I'm going to tables that we have in your manuscript. I'm going to here. I'm going to table. I'm going to table 3. In this table, I have some chemical informations about the meat, for example. In here, we have bovine meat that I have called beef, and I have chicken meat. Look, I have chosen some variables, water levels, proteins, lipids, cholesterol, ashes, calcium, magnesium, and we have in here your samples. We have in here our samples, and in here we have our variables. I can load this data, and I can see if I can separate bovine meat from chicken meat using these variables and the principal component analysis. Well, let me see how it works. Just a little detail. Just a little detail. You can see that this data was in Microsoft Excel format. When you have in Europe or in Brazil, if I have, for example, if I am in Brazil or in Europe, if I have $1, I have $1. If you are in North America, I have $1. I have 1.00. This data will be opened using Chem if you are in Europe, and if you are in North America, when you open this table, you are going to see a point instead of comma. Well, let me load my data. I'm going to load this data. I'm going to here. I have to close my app. I'm going to close my app. Key the app. I'm going to key in my app. Now I am going to load my new data. I'm going to factor mine. I go here, read test data from a file. I select in here. I have some missing variables that I'm going to show here. I am going to specify how these variables are separated, and I go to commas. I am going to factor mine. I am going to principal component analysis. I go apply, and I have in here my principal component analysis. As you can see here, samples were separated in here. Well, looking to here, this graphic don't show anything to me because I don't know where are my bovine meat and where are my chicken meats. Well, I have to go to the chain again. I'm going to chain. I just need to type ECR chain dataset. I have my data in here. I am going to place show principal component analysis parameters. I am going to here to show class. I am going to here show graphic options. I am going to here points color depend of the categorical of the variable. Now I have chicken meats like red, and I have bovine meats like black. As you can see, what you can see here, you don't have any separation of the samples, and I have some outlier samples. Outlier samples are samples that are very different from the another samples. For example, if I'm going to here, contribution, and I say to him, show just 8 of the samples that have the, I am going to here. When I am here, I am showing all the number of my samples in this plot. If I put down this number, I will just less samples names. For example, I go to here, I just want to show 8 sample names. You can see that these samples are the samples that have the highest influence over my model. These samples had a high influence on my principal component analysis model. And it was not a good choice you use it. In this case, I am going to take off these outlier samples. In table, in table 4a, I have take off these outlier samples. Thus, I am going to load this data again. This data that I am going to load in my software is the same data that I have loaded before. But this time, outlier samples were taken off. For example, I am going to load the same data that I have loaded in here, but I will take off these outlier samples. You can see, for example, in here, these samples, for example, have a high influence of just variables. Another thing that you can see, values. You are going to values. You have in here eigenvalues. And here, in here, I have the importance of each principal components. For example, the first principal component show this percent of the total variation. The second principal component shows just this percent of the total variable. With two principal component analysis, I have this percent of the total variation explained, and so on. In here, I have my original data. You can see the original data that you have in here. I'm going to load my data. I have to kit my app. I'm going to kit my app, kit app. I am going to kit my app. I am going to R again. I go to here, factor minor. I am load my data. Now, missing data, I have represented as TR. And the my specification always will be this. And in here, I am to use comma. I am going to OK. Yes. I am going to load table S4. I have loaded my data. I am going to principal component analysis, and I will go to apply. I have my data in here. You could see that my principal component analysis have completely changed before the exclusion of outlier samples. I don't have any good information here. I have to go to the Shiny to show a good visualization of my data. I'm going to here again, and I will type. Now I have my data again. I could go to show PC principal components analysis parameters. I'm go to here. I select class, and in here show graphic options, I go to point color of dependent of categorical variable. I am show you here, and look, you can see that once again I don't have a good separation from bovine meat from chicken meat. Well, what could I do now? Well, my principal component analysis were not able to separate bovine meat from chicken meat. How could I work with this data? How could I work with this data? Well, I can do variable selection. How can I do variable selection? Well, I can go to my table and I can delete, I can see the variables that are more important for my model. How can I do it? I could use f-test and t-test. You can perform the f-test or t-test in here. For example, I will begin my variable selection use f-test. Please, my Microsoft Excel is in Portuguese. Microsoft have changed Excel, and some commands that you use in your Portuguese version of the software were different from the commands that you type when you are in North America. But there is minimal difference. For example, in Brazil, I write it test F, and I select my variables. For example, in here, I am going to insert variables that have bovine meat, and I go to variables that have chicken meat. Well, now I have f-test done. Please, if you are in North America, the command that you have to type in Excel is very close that was typed in Portuguese. For example, in Portuguese, you are going to write it test F. If you are in North America, you are going to do the same thing that I do, but you are going to do F test. It's very close. What this value say to me? This value say to me that, for example, I multiply this value by 100. I just have 18% of the variable that are equal in both classes. Thus, I can assume that the variance in bovine meat and the chicken meat for water levels are the same. And in here, I have that. In here, I know that variances in bovine meat and in chicken meat are the same. Well, how could I do it? Now, for example, now I can do the t-test. I am going to the t-test. I'm going to type. In English, is the same thing, but I type t-test. In Portuguese, test is teste. is the Portuguese is a language that is very close from the English language. And in here, you are going to put, I have matrix 1 is the data from my bovine meat. In here, I have variables that is for my chicken meat. Here, I have one tail or two tail. I am going to choose two tail because I want to see the variations in the two sides of the distribution. I will put in here now that I have equal variances. If I have equal variance, I will type 2. If my variances were not the same, I will type 3. I'm going to multiply it by 100. And I know that water levels in chicken meat were different from water levels in bovine meat because I am doing to a 95% confidence interval. I'm going to 95 confidence interval, looking here. Thus, if my p-value is smaller than 0.5, I assume that the variables are different, that water levels were different in bovine meat and chicken meat. I just can go to here and I do this. I am going to look in here, for example, in here I have, look in here. Now I am going to water levels. As I have shown before, water levels in chicken meat and bovine meats are the same. The same thing happens for proteins. The same thing for lipids. But for cholesterol, look in here. Variances are different. So I am going to my t-test, and in here I am going to type 3. I am going to look in here. I can see that protein levels are the same for chicken meat and bovine meat. The same thing happens for lipids. But for cholesterol, the levels of cholesterol in bovine meat and in chicken meat are very different. For example, I am going to look with my data. Now we are going to work with table 4b. What I have done, this table is the same table that table 4b is the same as table 4a. The only thing that I have changed is that I have done a t-test and I have deleted variables that were equal in both classes. For example, I will do again my principal component analysis. I am going to do it again. But what I'm going to do, I don't use, for example, protein levels, because I can see that protein levels in both classes are equal. Thus, I am going to delete this variable. I am going to take off variables that were equal in both classes. I know that protein levels in bovine meat and in chicken meat are the same because I have a p-value that is much bigger than 0.05. I can see in here that is a 32%. Well, I will not save this one. I just close. And now I am going to work with a data where I have deleted these variables that is in here. I go to here. You can see my data in here. These were the variables that were different in both classes. I will load this data in my software, and I will run principal component analysis again. How can I do it? I'm going to, first I go to Chem. I have every time that I go to a new data set and work with it, I have to quit the app. I am going to quit it. I go to R Commander again. I am going here in Factor Minor, read text data from a file. I'm going to here. Here I will type PR. Here I am going to specify, and in here I am going to commas. I will type yes, and I am going to my new data set where variables which were not important were taken off. I'm going to open. I have opened it. Once it is opened, I can run my principal component analysis. I just click in apply, and I have my samples separated, and then here I have the contribution of each variable to my principal component analysis model. Right in here, looking here, it's very hard to see anything in R Commander. Thus, I have to go to the Chem. I'm going to the Chem. I go to here, and I will type PCA Chem dataset. Now my data is loaded in Chem. I go to show parameters. I am going to choose. I want that class where show. I am going to show my classes. Oh, I have to select all, and now I selected the classes. I go to here, show graphic options. I make these points a little bigger. Points color dependent of the categorical variables. Now I can see that my samples were separated using just important variables, which are water level, niacin levels, calcium levels, sodium levels. I have separate bovine meat from chicken meat, as I am showing here. If I want to save my image, I just go to here. I will choose the format that I want to save my data, and then clicking here to save it. Well, I have selected several examples to show you how to work with your data set. Just examples were given in my manuscript. I ask for apologize for my language. I am a Brazilian teacher. My supervisor during my doctor, when I am getting my doctor degree, my supervisor is North American. She was a nice person. When I have the opportunity to work with Professor Carol Collins, she already have a high age, but she is very nice, and he teach me a lot of things. She was a native North American, but she likes to speak just in Portuguese. I have lived all my life in Brazil. Science of my time with Professor Carol Collins, I have written some papers in English language, but I never have the opportunity to speak the English language. I have written something over my life, but I don't have the opportunity to speak the English language. For this reason, I believe that some words that I have done here, that some words that I have spoken here could be a little different for a native North American or a native or for a native English speaker. But I have tried to do my best to show you how could you load your data in R Commander and how can you work with this data in R Commander. I appreciated very much everybody that can see this video, and I am very happy if someone use this manuscript to teach principal component analysis. As I have said in my manuscript and in the beginning of this video, I have been working with principal component analysis for a long time, but every time that I'm going to teach this approach, I have the trouble that I didn't have a software to do it. Some time ago, I know this R Commander. In beginning, I was hesitant to use it because I think that it could be very complicated. But R Commander has a very visual interface, and it was not hard to work with. And it's a very simple software. It's very simple to work with data on it. And it's a good choice to teach principal component analysis. I just to show you a last example before I finish this class. For example, this data in here. I have taken from a manuscript. This data was taken from a manuscript in Journal of Chemical Education, where they are trying to group oil samples according with the class. For example, I have canola class, I have canola oil, I have corn oil, I have olive oil, and I have unknown sample. I want to place my unknown samples close to samples that I know the class. I can do it using, in here, we have the intensities, of some, in here we have the intensities of nuclear magnetic resonances. When I load this data in R, I am going to load this data to you see what I am talking about. I'm going to load this data. I don't have any missing variable. I am going to specify it, and I am going to come to point. Okay. I am going to this table. I will load it, and I will run my principal component analysis. In here, I have canola samples, and in here we have another samples. I can load this data in Shiny. I am going to keep my app, and I am going to load this data in Shiny. I'm going to type PCR Shiny data set. I'm going to show principal component parameters. I may go into class. I may go to show graphic options, and then you go to point colors depending of the categorical of the variable. In here, we see that canola samples were very, very different from another samples. Thus, canola samples were placed far from other samples. These results that I am showing here to you are different from the results shown by my colleagues in Journal of Chemical Education. It was done because they processed the data with another processation manner. In R Commander, I just find nice use of normalization of the data before the analysis. Thus, you can see that data treatment could influence very much your principal component analysis model. Well, this is the last example that I am showing to you. I expect that you appreciate this manuscript. And if you like this manuscript and if you like this video, please, you can talk to me using my email. Regards.